Welcome everybody on behalf of Francesco Pignatelli, the ELISE Action Leader, Lorena Hernandez, Project Officer of Joint Research Center of European Commission, and myself, Simon Vrečar, Consultant at Joint Research Center of the European Commission, who together will be co-hosting today this webinar with the title Monitoring and Understanding Emerging Geospatial Technologies. Maybe first a few words about ELISE, as you can see on the next slide. So for those who don't know about ELISE, ELISE stands for European Location Interoperability Solution for e-Government. And this action is actually part of the ISA² program, which is an European interoperability program aiming at providing cross-border and cross-sector interoperability solution for public administrations, businesses and citizens. So under this program, there are 54 different actions tackling interoperability from different angles. And ELISE is the only one amongst them focusing on the location dimension as a driver for enabling the digital government transformation. So on the next slide, we have a bit to explain about the ELISE knowledge transfer activities. So under these activities, we are periodically organizing webinars whose aim is actually to engage in some agile way with topics of relevance to the digital transformation by harnessing the use of location data. And of course, with the aim to share and present all the results that are actually produced under the ELISE activities. So for more information about our webinars, you are kindly asked to visit our Join Up webpage. At this moment, I would just like to remind you on some special webinars that we prepared recently. Dedicated to the location intelligence for regions and cities. So there is still left one part of this puzzle, which will be present on 14th of October during the European Weeks of Regions and Cities. We'll tell you a bit more about that at the end of this webinar today. So how to register, and you're of course welcome to be there with us as well. So coming back on the next slide. Coming back to today's webinar, so a lot has been talking about the new technologies and trends, different kinds of big data, data analytics, blockchains, Internet of Things, cloud, fog, edge, and so on. So location authentication and so on. So all of these energies, most of these technologies have certain impact on our work, let's say. So that means on the geospatial sector in general. And on the other side, the geospatial sector is also contributing to the developments of this technology, and also to create different solutions that make the use of these technologies. So today, as you can see on the next slide, we have two speakers with us. Danny van der Broeke, senior researcher from KU Leuven, and Go Bechobona from OGC Standards team, which together with the ELISE GRC team have done research for this webinar today. They will walk you through different topics. So to present you the key drivers, general trends, how monitor and assess different technological trends. So they will give you an overview of the major trends, what are the interoperability challenges and efforts, and what are the ways that you can get acquainted with the new technologies. But before we go to the content into the webinar, I would invite you to do the polling. So to see a bit where are you coming from, so what is your affiliation, and what are you actually expecting from this webinar. So the poll has been started, so kindly ask to vote, please. So let's say 20 seconds for voting. So do we see what is the demography of the people today, and what are your expectations? Okay, so let's end the polls. So it looks like that most of you are from the academia and research, and as well from the European Public Administration. So what would be your expectation? So you would like to get the overview of the major trends and how they fit together. I think these are the good inputs for Dani and to Gobe to start with the webinar. Please, Dani, the floor is yours.
Thank you, Simon. Do you hear me?
Yes.
Okay, then I go ahead. Also welcome from my side. So I will start kick off this the content of this webinar. Maybe I first go some key messages that we want to stress throughout this webinar. First message is that we see a lot of technological trends emerging. Others are already for some time there and are becoming mature. But we hear a lot from different people, different organizations, that it's often difficult to see the wood for the trees. So there are many emerging trends, there are many things happening. In order to monitor and understand these trends, we know that they are interconnected. We think that there is a need for a comprehensive technology trends watch, so a more advanced system to really understand, to monitor the interrelated trends. The third message from this webinar will be that all these trends lead also to kind of revision of our traditional SDI architectures and the related standards. So these are evolving too. And this is of particular importance for the ISA2 program that is, of course, focusing on interoperability issues. So it's clear also the geospatial technology, the data management, handling and processing of geospatial data, because of these trends, these are changing rapidly as well. So that are the key messages. And I will first dive in a little bit on what are the major drivers in the geospatial sector. And in fact, this work is based on one very important or a few very important publications from UNGGIM that has developed a future trends document. Already the third edition has been released now in 2020. And there is their work done and an identification of 5 key drivers and 31 related trends. So I want to focus a little bit in this section on the drivers. So it's not only about the technology, so that's quite important to understand. Of course, we have one of the drivers is the enormous amount of data and different new data sources. And related to that also, the way we handle and manage these data is shifting dramatically. While 20 or 30 years ago, it was difficult to find the right information, the right data. Now there's an abundant amount of data, and sometimes it's very difficult to find the right information that we are looking for. So that's changing dramatically the way we work, the way we live, the way we understand what is happening. Of course, the technological advancement themselves is another key driver. There are in all subsectors and sectors of society, there are technological advancements. They influence each other a lot. So, and that has an impact also on the geospatial sector. But the third is even maybe, in my opinion, personally, one of the most important drivers is that there is a lot of user expectations. Citizens, businesses, everyone in general in society is expecting a lot, and everyone is connected with each other. So there is a lot of expectations. We need instant access to everything, etc. Together with that, there is also an industrial structural shift. So the way industry is working is changing dramatically. Also the interchange, the interplay with public sector actors, with citizens, with other peers is dramatically changing. And the last element is, of course, that all this is happening in a political, institutional, and a legal context. And the legal environment and requirements is also kind of driver. On the one hand, we want to share more and more, everything open, but on the other hand, we want also to protect some of our data and our information. So these are the 5 drivers identified by UNGGM, so by the geospatial community, let's say. And of course, there are particular things happening in society that has, or that have also impact on what is ongoing. Of course, we have to keep track of all the political realities, what is ongoing, geopolitics at large, so in the whole world. Of course, we have things like COVID-19 that has dramatic impact over only the last 6 to 8 months already, and that will continue to have an impact. There might be other things similar to COVID. There are economic elements, population change and developments, environmental pressure that we need to take into account in everything we do. And of course, the values in society of people, of organizations are also not blocked and fixed. They are dynamic and evolving. Against that backdrop, we know also that everything happens somewhere. And we can say that with, for example, smartphones, geospatial has entered the mainstream. Everyone is using Google Maps or any other device like a GPS in the car or whatever. And everything is changing, and more is more and more location enabled. And so the way we, as a citizen, as a person, consume services also is changing. And one of the highlights there is that it's not enough to have static information in a kind of infrastructure through maps on the web, but we need near real-time information, dynamic information on events, etc., combined with other information. And it is expected that in the next decades, geospatial information will become even more important and influence, in general, the global economy. If we look into a few highlights on the different drivers then, so one, if we speak about technological advancement and developments, we don't speak about one particular development, one technology, but it's many developments, and as I said before, they are interrelated. The geospatial industry is driven more and more by automation, artificial intelligence, sensor technology is a major part of the industry now, and we make the link to Internet of Things. And there is abundant data, many data sources. There are so many data that it's hardly and very difficult to manage everything. And mostly the biggest part of the data is coming from mobile data collections, crowdsourcing, social media. And that really is a kind of tsunami of data and information. And that will have a very big impact on the next decades. The other drivers that were mentioned is the industrial shift. We speak mainly about a lot of automation, more and more intelligent application using AI, so that people in industry might be freed up and focus not anymore on repetitive monitoring or collection of data tasks, but rather that machines will take over and that we can focus more on higher value tasks. As we said, also the user requirements are really a push factor, a driver, and that's this real-time data and frictionless. So it has to come when we need it, in the right time, at the right place, for the right people. Usually we speak about the interconnection between different people. We live in a network. But of course, there is the backdrop of the legal environment that we have to take into account, and there we can refer, and in the report of UNGGM, it is the reference made to the Cambridge Analytica and Facebook data scandal of 2018, which of course requires us also to look into ethics, into privacy issues and new regulations. Okay, that's the drivers. Now, the second section, we will zoom in on the technological developments, the trends, and we will have an overview on the different aspects related to that. But there is first a few questions again.
Yes, before going to this section, we would like to pose a few questions as well for you. So since we have a speaker from OGC as well, are you following the OGC technological trends monitoring activities? This is the first question. And the second one is about the purpose you want to monitor technology trends. So please take a few more seconds for answers. Okay, so 2/3 of you answered. So on the first questions, I heard about the OGC Trends Watch, but did not follow it actively. And the purpose of monitoring is actually, most of you answered, to plan modifications in our work processes, data production, and decision making. So, okay, please, Danny, continue with your presentation.
Thank you, Simon. So we dive now a little bit deeper into different mechanisms that are in place, studies, etc., for monitoring and assessing trends. So it's going from isolated studies to really technology trends watches. If we speak about monitoring trends, what do we speak about? That's the first question, of course. Do we speak about disruptive technologies? What is a disruptive technology? You can dispute or discuss about that. Because some of the trends are already there for a longer time. For example, artificial intelligence was coined for the first time in a workshop of Dartmouth College in '56, so already some time. Also, if you go online on the web, you will see that some people, some organizations assess certain technologies as disruptive, while maybe for geospatial ecosystem and community, it's already old, between brackets. The example is given by Smith and Scott, who refer to e-commerce and GPS systems as disruptive technologies, still stating that in 2020, while we say, okay, GPS is already for a longer time there. We also see that various terms are used. We speak about future trends, disruptive technologies, technological innovation. So in what we do, in fact, we look at it in a broader context, not only disruptive technologies, but also the emerging trends, and we monitor their development. Why do we need monitoring trends? Why is that useful? There might be many reasons for doing that. Some organizations want to monitor it because discovering new markets or business opportunities. Some say, okay, we need to integrate new technologies in our production process, so to increase efficiency and effectiveness, or the performance of ICT systems, in particular. Others, they look more in technological trends to try to answer complex problems, and probably the list might be a lot longer. It's also clear that many people in the IT sector, in the geospatial sector, and other related sectors, they follow already technological trends in a certain way, because they need to know what is happening, what's ongoing, and what might be relevant for them. In the right part of the slide, you see some of the top 10 strategic tech trends mentioned in the report of 2020 by Gartner, where you see particular aspects or implementations of technologies like human augmentation, artificial intelligence security, not only autonomous vehicles, but other autonomous things, etc., etc. So when we speak about the trends, annually these studies are being made, this monitoring is done. It's evolving, so it's the focus is not necessarily every year the same. There are many organizations, very known organizations, that have publications or annually or every 2 years or so, or at least regularly. They focus on, let's say, individual studies. There are many very interesting ones from Deloitte, Gartner, PwC, other similar companies. And usually they cover many aspects. Usually they're quite descriptive. They deliver the context. Why are these trends emerging? Sometimes they focus on case studies, examples that dive deeper into particular aspects. In some cases, like for example, the hype cycle of Gartner, the idea is to have kind of maturity assessment. Where are we in the curve of development of the trend, and when it is applicable in a certain context or not? And of course, also there are different views. Sometimes the view is for companies. In other cases, in other studies, it's rather the governmental perspective. And as I said before, a lot of these studies are repeated, sometimes annually. But technology trends watches and studies exist also in particular organizations. These are two examples of two organizations that are also very relevant in our sector. In the space sector, we have companies like Airbus or the ESA, the European Space Agency, that have their own. Airbus has its own tech trends watch to develop new technologies that might be relevant for, of course, plane productions, but airplane productions, but also for the geospatial part. Recently, ESA developed, or they sent out a call for tender to have also for position navigation and timing sectors, PNT, a specific technology trends watch to see the particular changes and new trends that will affect those particular subsectors. So a lot of initiatives are ongoing and emerging in different places of the world. But before going to the first example of OGC, is still an interesting publication, which is called Persistent Forecasting of Disruptive Technology. That is the publication that provides an overview of what is a methodology, how should we monitor or not disruptive technologies. So the book covers different aspects. It covers the need for persistent long-term forecasting, which is something different than just monitoring technology trends. It's also focusing on the methodologies you can use, also warning for some potential bias, discussing potential attributes, what are the elements for forecasting systems, and also evaluating some of the existing forecast systems and software tools. So this is an interesting publication that also has been used by the OGC, for example, to set up its technology trends watch. And I think I will hand over now to Gobe for explaining more on the OGC case, how they do it and why they do it.
Okay, thank you, Danny. I take it you can hear me clearly?
Yes.
Okay, that's great, thank you. Hello, everyone. So my name is Gobe Hobana. I work for the Open Geospatial Consortium, also known as the OGC. I'm part of the team that monitors technology trends. The team is led by George Percival, OGC's Chief Technology Officer. So why does the OGC track geospatial technology trends? A number of years ago, the OGC Planning Committee, which consists of the strategic and principal members of the OGC, identified a need to address the evolution of technology and markets with regard to new standards, how new standards can help, how new standards should be developed in order to leverage some of those emerging technologies. So OGC embarked on a technology trends monitoring initiative, which we refer to the OGC Tech Trends Initiative, with the view of providing unique technology assessments that focus on the geospatial domain and assess the implications and the impact of those technologies on geospatial technologies and standards. And we use those assessments to plan our internal R&D activities, which inform the standardization work that the OGC conducts. Next slide, please. Okay, so the Technology Trends Initiative within OGC is part of a broader set of activities that run within the OGC. What you can see on the slide is the cycle that effectively links together the Technology Trends Initiative to the Innovation Program, which runs test beds, pilots, hackathons, sprints, and other activities, and through to the Standards Program, where you find the standards working groups that actually write the draft specifications and pass those specifications to the OGC membership for approval. So the insight that is gained from the Technology Trends Initiative informs the research and development that takes place in the innovation program. And the lessons identified in the innovation program inform the work that the standards program runs within those working groups. And that eventually leads to the development of the standards. Now, we also have domain working groups in the standards program. Those domain working groups help set out the requirements and needs that then inform the Technology Trends Initiative. So we have this continuous cycle from technology trends right through to applied standards. Next slide, please. And the way we assess those technology trends, we start off by looking at the breadth of technologies that are out there, technologies that are emerging right across industry, academia, government, and elsewhere. So we assess those technologies, that is assessing the breadth of the technologies to identify and prioritize those trends. And that results in the mind map that you can see on the bottom left hand side of the slide. We then move on to the next stage in the process, where we assess individual technologies and evaluate the clusters of trends. And that results in some trends clusters that effectively give us a view as to how some of those trends might evolve. With many of the trends, it's the convergence that ultimately leads to also what I'll refer to as just a disruption, or as to that leads to a step change in how technology is applied in society. So, so in the second stage in that process, we evaluate the clusters of trends. And then finally, in the third stage, what we do is to focus on a specific trend and then pull it into our standardization process. So we plan test beds, we plan pilots, sprints, hackathons, and other standardization activities. And that's the point at which we are now pulling that technology trend through to eventually become part of a future standard. So that is the three phase process that we go through, from reviewing a breadth of technologies to identify and prioritize trends, to assessing and evaluating clusters of trends, and right through to focusing on a specific trend and acting on that particular trend to bring it into a future OGC standard. Next slide, please. And to assess the breadth of technologies that are out there, we conduct a very broad literature review. So we conduct a review of literature from academia, government departments, OGC members, commercial organizations, companies of all kinds. And those, and the literature includes peer-reviewed journals, magazines, OGC reports and other documents, industry publications, including market sector publications and magazines as well. But we also hold a series of activities through the course of the year, including, for instance, the Location Powers Summits, as well as the Future Directions workshops, and also produce discussion papers and engineering reports. The location power summits are held about twice a year or so. It depends on the topics that are explored. But we also hold future directions workshops every quarter. Now, what you can see on the right-hand side of the slide is an overview of the topics and trends that were identified from a review that we conducted between November 2019 and May 2020. That review included 446 documents in total. And what you can see there is a view as to which topics came up, which trends came up, and basically the occurrence of those topics throughout the corpus itself. So that gives you a view of how we actually collect the information that we need to help us produce the analysis that we produce as part of this initiative. Next slide, please. Okay, thanks. So in addition to the literature review, what we also do is to use a variety of tools. And we've also recently worked with a company called Big Knowledge to develop the Geospatial Technology Explorer. So this is a tool that helps us to understand the technology trends as well as the relationships between them. To develop the Geospatial Technology Explorer, what we did was we processed a corpus of more than 100,000 document artifacts, and those documents included textbooks, standards, manuscripts, engineering reports, research journals, and glossaries and so many other documents. And we worked with Big Knowledge. They have a natural language processing process that processes that corpus and generates a relief map, and that is what you can see on the right-hand side of this slide. The way the trends are presented on this relief map, the trends that are, the more the trends are closer together on the relief map, the greater the number of documents that relate those trends together. So that immediately gives you a view as to some of the convergence that's identified in some of the research and other publications that are out there. What you can see on the left-hand side is the URL if you'd like to try out the Geospatial Technology Explorer. It's publicly accessible. Next slide, please. So all that analysis then enables us to identify the top-level categories, and that's what you can see on this slide. So we have a number of top-level categories which help us to group the trends and to associate those trends, within the context of a single theme or a single category. The top-level categories change basically about maybe once a year or so. And the change is it's gradual. So next year you don't expect to see a complete overhaul of the top level categories, but maybe 2 or 3 of them might fall off the top level category list, and you might find 2 or 3 additional ones added there. So these top level categories help us to group and analyze the trends that we identify in that literature review, as well as in all those events that we hold, future directions, location powers, and others. Next slide, please. And within each technology trend, there are a number of, within each top level category, there are a number of technology trends identified. And that's what you can see on this slide. Now, one key point about these trends as well is that some of these trends are new in terms of their emergence and impact in the geospatial community. However, others have evolved in recent times. So, they might have been there for a while, but they have reached a certain point in their in their evolution, where they're making new impact and creating a step change in how they are applied. I'll give you some examples. For instance, there's the discrete global grid system. Now, that is a technology trend that OGC has developed a standard for, an abstract specification for, and we're currently working with ISO to publish the next version of that standard, which will become a joint OGC and ISO standard. But also we've got underground models, which is within the spatial temporal models category. Now, underground models, we recently established a standards working group that's going to be focusing squarely on underground data models. However, in addition to those trends that we've already brought into the standardization process, there are other trends that are new to our community, and trends that we are starting to to discuss the requirements for. And an example of such trends is blockchain. We recently established a domain working group. We haven't established a standards working group yet, but that domain working group will help us to understand that area more and to help highlight the standardization requirements for that particular community. Another area is artificial intelligence, as well as machine learning. So we have a domain working group. So with these technology trends, they help us to understand the the landscape. The analysis helps us to understand the landscape, and then we can react to that to that change in landscape by setting up standards working groups, domain working groups, and other activities to help us identify the standardization requirements and ultimately produce standards for that particular trend. Next slide, please. And with many of those trends, they eventually converge. So in some cases, they'll converge to create another trend. In other cases, they'll converge to address a particular social need. An example of a number of trends that are converging to address a social need includes, for instance, location-based services, including Bluetooth and others that are converging to respond to COVID-19. Others include, for instance, geospatial data science, where we have just geospatial statistics, machine learning and AI approaches that are converging to help us take advantage and apply data science to areas that where basically society has a need for those technologies. So with a lot of these trends, we're seeing convergence, and where multiple technology trends converge, typically that results in a new trend that addresses a specific social need. So that's, I think that is the last slide that I had. Next slide, please. I think that's back to Danny.
Yes, thank you, Gobe. The second example I will briefly present is the use of the monitoring of technology trends in the context of educational requirements. So EO4Geo is a sector skills alliance for the space and geospatial sector that tries to bridge the gap between the supply and demand for skills in the sector, and in that way also improve the user uptake of Copernicus. In that context, there is the development of a skills intelligence exercise, where an assessment is made of the supply and demand, but also new technological and non-technological societal trends are assessed and how they will influence or influences already the skills requirements in the sector. And then this is used to develop a strategy to fill the gaps. And also in practical terms, new identified trends are feeding a body of knowledge that is then used to do curriculum design, etc. So the schema on this slide is providing that a little bit. I will not go into the details what the body of knowledge is, but in short, it's in this case, in our case, it's an ontology-based body of knowledge describing, in fact, the professional domain, all concepts, theories, technologies, standards, whatever, they're described in a body of knowledge. And so we use or want to use a technology trends watch to feed the body of knowledge, to evaluate also maturity in terms of when do we need and how do we need to provide education and training on the new topics, how should we do that? And then the body of knowledge is also used to define research project, to design curricula, etc., etc. So it's in practical terms another way, like in OGC, it's more to steer the standardization process. In our case, it's a way to steer, in fact, an educational process and vocational and academic training. Very important is that in this body of knowledge, it's always difficult to make the exact match of what is our domain. We speak about GI and Earth observation, science and technology, but we know it's not only the science and technology, it's also the applications, but there is also a link to many other areas, scientific fields, etc. And so our body of knowledge is a little bit broader. And I think also in the way OGC is monitoring technological trends, it's not in a narrow sense, but it's rather in the broader sense. And there are many links and hooks to ICT, to other domains, of course, because geospatial is not occurring in isolation. So that's the second example, and I think there will be a new poll now, if I'm not wrong.
Yes, indeed, Danny. So before to continue to the next section, we would like to ask you a bit about which technological trends areas do you plan to experiment with or even might implement? So may it be data analytics, machine learning, digital twins, immersive visualization techniques like augmented reality, virtual reality, indoor models and positioning, APIs for the web, sensors, web and data streams, modeling, advanced analysis and predictions method, cloud thought and edge computing. So yes, you're voting. Let's have maybe another 10 seconds for voting. Okay, again, 2/3. So obviously the most of you are for APIs for the web and for modeling, advanced analysis and predictions methods. Okay, let's see what Danny will share with us with major trends and how to fit together.
Okay, of course, in this short webinar, it's impossible to discuss all the technological trends. Also, it should be noticed that there are several other webinars of ELISE that are focusing on digital twins, on geo APIs, geo AI, etc. Also on APIs, there is one or two webinars in the past, so they are still available. What I want to showcase here in this section is starting from this branch, this mind map of all kind of technological trends, is how you can use it in concrete cases. In our case, it's to do research or to prepare education, etc. And the first example, I want to give briefly two examples. The first is the use of what we call agent-based spatial modeling. Very concrete case where an assessment was made of behavior of children in traffic with starting questions, R&D questions like how do children and smaller kids especially experience their environment when they go to school using the bike, for example. What do they see? What do they not see? What do they focus on? Maybe you have different types of kids, different typology, different type of behavior. So this was done using different type of technological technologies. And was going back, of course, to basic elements such as spatial thinking, the spatial brain, spatial experience, how youngsters conceive their environment and experience their environment, especially. And that was related to how they behave in space, in their environment, in this case, in a traffic situation. So that's related to human activity modeling, or we call it also sometimes agent-based modeling. And for that, you need to have these rich digital twins, not only with 3D city models of buildings, but you need also furniture, you need all the elements that are in the environment, physical elements and non-physical elements, but also, for example, the moving cars and the moving bikes and motorcycles, etc. And in this context, of course, you need more advanced visualization techniques, such as augmented reality or virtual reality, gaming. Gaming would be a good solution also to train youngsters, for example, and that was the idea also, to have this output of this kind of testing and experimenting as input for urban planning, for example, to re-engineer crossings, to replace or improve the use of signals, to reposition even trees in the context of a particular setting, etc. But also in the other way around, using or adapting teaching programs at school, taking these experiences and these conclusions or these results into account. Of course, in this context also, typical or specific technology as eye tracking technology, eyewear, advanced eyewear was used to, well, in fact, to understand how youngsters were looking at their environment. The other example is more on automatic object detection in the field of Earth observation. Where one specific goal was to have a better insight in how refugees flows are happening, especially at borders of the European Union, how we can automatically eventually discover vehicles and boats using huge amounts of images, because that's of course the challenge, the big data streams. Of course also boats and vehicles, they are moving, so it's not fixed. So you need a very complex and advanced analytical mechanism and approach to find, to say so, the needle in the haystack by using, in our case, machine learning and deep learning. And the results could be then used to discover these flow patterns, behavior of groups of people, etc. And the ultimate goal was, of course, to use that as an input for security policy, etc. But the technology trends used there were, of course, on big data, huge volumes of data analytics and performing data analytics on bigger amounts of data, although the focus in reality was not much on that one, but rather on the algorithms to detect automatically certain objects. Use of machine learning, use of different types of satellite imagery, not only from Copernicus, but also others. But also human activity modeling was in there. And then in the long term, the processing power will need some new technologies such as quantum computing. Of course, in this context, there was also particular IT ethics that was to be taken into account, although we did not really work on it. But this gives you an idea of flavor, how different technology trends can be used and combined in particular settings for particular R&D projects or educational projects, or a mixture of those. I want now to zoom a little bit, and it's a short section as well, on the effect or the impact or what is happening related to interoperability efforts to be made based on all these changes we see. And I want also only to introduce it to give you a flavor. There is also in the reference list a lot of interesting literature taken into account and available. First element to raise, of course, is that we probably, with all these developments, these new technologies, and this is based on an article from Kotsev and other authors from the GRC, that put the discussion on the table of we are going from traditional SDI architectures where we have the publish, search, find, bind paradigm using portals, towards a more mixed environment where we need to work together at the data tier level, of course, because it's not only the typical public authority mapping agency, etc. Type of data, but it's also data from private sector, from people, from citizens, citizen data. It's coming from all kinds of sensors, physical sensors, etc., etc. So the data there is already changing dramatically. And with the API developments, we know also that the way of service-oriented architecture is shifting more towards other ways of providing access and providing the data themselves. And also at the application tier, it should support many different type of applications, whether it's, for example, at European level e-reporting, but it can be also other things at global level or even at local level. And of course, this is a big challenge in the European interoperability framework. You have not only have the semantic and technological or the technical interoperability, but also the organizational interoperability. And bringing together all these efforts requires also another way of harmonizing or standardizing data. So we all are actor, or we will become all actor in providing pieces of the solution in this type of infrastructure. And you see it already, what is happening in the standardization world alone is you don't have only ISO TC211 and OGC working on these issues, but more and more OGC and ISO are working in conjunction with other ISO committees, with OMG, with W3C, with IEEE, or with specific standardization efforts or associations that are focusing on particular areas. I've just put here a few of them where you can see already, and this is not complete because it did not match on the slide, but you see that many are involved. So also the standardization worlds are coming together, and co-creation of standards in an agile way is a new paradigm or a new way of doing things. You can see this already in OGC work. Often when I speak with people from public sector bodies or even academia, they say OGC, that's WMS and WFS, that's what they know. But already for years, it's working on different things, other things, indoor, smart cities, 3D, sensor web, moving feature, secure access challenges, the semantic web APIs, etc., etc. And also the way the development is done and the standards are made is more interactive. For example, now with the API sprints, it's interesting to see. Another impact on the standardization will be, of course, on the way we look at semantic models. Myself, I'm a lot involved in the SPI development, but okay, still traditional data models where we put everything in UML, nicely defined by the community. It remains, it's still relevant, but more and more we see that other approaches for reaching semantic data interoperability is emerging, like they do in the OpenStreetMap initiative or in Darwin Core Archive on biodiversity. They do it also in different ways. So it will be smaller building blocks probably, and also we need to do it differently because others like citizens and public sector actors will be more and more involved. And therefore, it's kind of call to also have more collaborative experimenting. Also, the OGC is a good example of doing that already to a certain degree, but we think that we should expand this also in the way we work together in harmonization efforts, etc. Whether that's a persistent test bed or a sandbox or a living lab or collaborative platforms, we see these emerging as a way of trying things, experimenting, working together, and that can take many forms and shapes. And with that, I think we will go, before going to the key takeaway messages, to another poll, the last poll, I think.
Yes, indeed. So in the last poll, we would like to ask you about the topics you want. The future release webinars are focused more in the future. So the topics that were listed before, so were the data analytics, digital twins, we had already digital twins something, immense visualization techniques, indoor models, APIs for the web, sensor web and event data streams, modeling, cloud fog and edge computing. So please take a few seconds for vote so that we see a bit in which directions we will prepare our future webinars. Okay, thank you for voting. So obviously, most wanted is, let's say, modeling, advanced analysis and prediction methods, and APIs for the web. Okay, thank you very much for your answers. So please, Benny, continue.
Okay, only 2 slides left, some conclusions or concluding remarks. So it's clear that technology trends, geospatial technology trends are influenced by many different factors, and not only the technology per se, but also economical, legal, and political drivers are there. We need really a consistent way of doing technology trends monitoring system. We need that so that we can really analyze emerging technology, how they are interconnected, how they might be applied to different contexts. Since they change very rapidly, we should not also wait too long, maybe in different organizations to try them out, to experiment. So that's one of, for me, one of the conclusions or one of the recommendations we could give, using different types of experimenting environments. It's also clear that we have many stakeholders involved in the geospatial community, that we should work together for having a good, strong technology trends watch and a real system that we can all use and reuse. It's also key for us that we could link this technology trends watch to systematically assess new skills requirements. And finally, okay, we don't know exactly the full impact of all these major technology trends. It's maybe not entirely clear on interoperability, and that requires certainly future investigation. And with that, I think I want to conclude and go to the question and answer.
Yes, thank you very much, Danny. Thank you very much, Gobe, for your very interesting presentation today. I think we've heard quite a lot of different things, new technologies, trends that are affecting geospatial sectors, geospatial technologies, geospatial trends. They're interrelated between each other. I don't see any questions in the chat, so maybe I will ask a question for both of you, Danny and Gobe. So seeing all that today, so in the past, there was a saying that the spatial is special. So hearing all this today, so what is your perspective on that statement today? So it's spatial, still special?
Gobe, can you start?
All right, yeah, so location. So location data and location information is now mainstream. So I'm intentionally avoiding using the word special there. But I want to highlight that location data is now mainstream. We have developers and end users from across society using location to address challenges that previously could not be addressed through spatial data. So I think from my perspective, spatial is mainstream. It's gone beyond just being a niche market, and it's made it into into homes and to parts of society where it wasn't there before.
Yeah, I agree with Gobe. What I still want to stress is that there is still a need, I think, for example, at secondary school level, to put location more in the forefront. We know all that geography, for example, is not very prominent in classes in schools, but location thinking, spatial thinking is something that everyone and every youngster and every citizen should be able to do. And I think that will, in that sense, it will be even become more mainstream, that it is drilling down not only, before it was for experts, then everyone gets started using as an adult the GPS or whatever, or Google Maps or Google Earth or other things. But I think it should be everywhere in society, and that will come definitely also with the new technological trends, which will make it more easy and to have location information integrated in regular applications, for example, for tourism, for all kind of things, in traffic management, in the way we also live and behave with each other. Even COVID-19 has stressed the importance of location, distance, spatial clustering. Now people know what these things mean. Maybe unfortunately, but it's the case.
Okay, thank you very much. So, as I understand, transforming from geospatial from vertical to horizontal, it became from spatial to mainstream, actually, which is still more important. There are some other comments, I think, in the chat for Knut. Knut, would you like to say something? Knut from ISO.
Yeah, can you hear me?
Yes, perfect.
Yeah. Yeah, I just wanted to add for this slide on the different words coming together, which was a very interesting slide, that we could also note that ISO TC211 is working closely together with TC59 on BIM standardization,
yeah,
and with TC204 on ITS standardization of geospatial information. So there is we have joint working groups with those two other technical committees. So
yeah,
like
yeah.
for instance, a future version of the GDF standard for ITS will probably be based on the same principles as ISO TC211 and OGC standards.
Mm-hmm. Yeah, I think it would be interesting, because when I was preparing this slide, I was realizing that there is a lot more, and that it would be interesting to map all these interconnections and joint initiatives ongoing, because I'm sure I forgot many, and there are, as you say, in different sub areas, there are a lot of initiatives, which is kind of good thing, I think, and that's happening more and more. So yeah.
Okay, thank you for these comments, Danny, Gobe, and Knut. I think there are no further questions. So please, before conclude, I would like to invite you somewhere else, as I mentioned in the beginning. So please, the next slide, Danny. As mentioned in the beginning, so at 14th of October, we will be present at the European Week of Regions and Cities with a participatory lab, Location Intelligence for Cities and Regions, where we will prepare this participatory lab discussing location intelligence, innovation through the eyes of the energies, efficiency and data ecosystems, and how this can be supported by cities and regions. So you are kindly welcome to register. So you have this register link, and you will also receive further information about that event in the communication with the slides of this session. Okay, so before to conclude, I would like to thank you, everybody, for attention and for participation today. Thank you, Danny and Gobe, for a very nice presentation. Thank you for all the comments. And as you can see on the next slide, please follow us on all the social media channels, and join the ELISE community in JoinUp as well, so that you will be able to follow, let's say, all the news from ELISE. Thank you very much, and bye-bye.
Bye.
Thank you. Bye.